Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Olive It in the Fog. Olive It in the Fog by Megan33. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that in every row, every column, and every designated 9-cell region, which is a box, in this case, I'll eventually get one, you have to have the digits 1 through 9 once each. The grid is partially covered with fog. Correct digits will clear fog around the cell. So this is standard fog of war. So if say you placed a correct digit in this space, it would clear the fog in that space and in the 8 surrounding squares around that cell. So that's how fog of war works. Cells along lines between two filled circles must have values between those in the circles. I think these are called between lines, I believe it's what's called. So basically, all of these digits on this line must be between the digits which are in these two circles here. Should we make an example? There's a lot here, though. Okay, so you could have something like, say, 1 and 8 here. And then you could have 2, 5, 4, 6, 7, 3. Because 2, 4, 6, 7, 3 are all between 1 and 8. So this would be a valid between line. I think it's what's called a between line. I don't know. It's been a while since I've done one of these, so I'm not really sure. I can't really remember what the actual rule set's called. Anyways, that's how that works. We have also adjacent digits along a green German whisper line must have a difference of at least 5. So for example, if this were, say, a 3 here, this would have to be an 8 or a 9, because those are the only digits which are 5 or more away from 3. And that's how example of how a German whisper line, or as I like to call them, whisper 5 lines, works. We also have adjacent cells connected with a V must sum to 5, and adjacent cells connected with an X must sum to 10. So for example, if this were, say, a 9, this would have to be a 1 here, because these two digits must add up to 10. And say we'll use the blue X as a V substitute. So if there was, say, a V here, and if this was, say, a 3, this would have to be 2, because these two digits would have to add up to 5. We also have a black dot between cells indicates cell values with a 2-to-1 ratio. A white dot between cells indicates cells with consecutive values. Not all dots are shown. So for example, if this were, say, a 2, this would have to be a 1 or 4 to maintain the 1-to-2 ratio between them. And say we use the green X as a symbol, as an example of a white dot. If this were, say, a white dot and this were, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive. And they're called Kropke dots. So that's how Kropke dots work. We have digits along a blue line. Create a sum line where the sum of the digits on a line within a particular 3x3 box must be the same for all the boxes the line passes through. So this is called the region sum line. I don't particularly like this rule description. I prefer the rule description that box borders divide a line into segments which must sum up to equal sums. So for example, say we had a line like, I don't know, this. Then this if this were, say, 3 and 5, this would have to be 8, because the box borders divide the region sum line into segments, which must sum up to the same sum. And 3 and 5 sum up to 8. So that would work there as a region sum line. We also have digits along a thin gray palindrome line read the same forwards or backwards. So as an example, say we have this black line, we're going to make it essentially a palindrome line. Then this could be something like, say, 3, 5, and 3. And this would work as a palindrome line because it reads the same either way, 3, 5, 3 or 3, 5, 3. And that's how palindrome lines work. We also have digits along a magenta red band line form a set of consecutive non-repeating digits in any order. So say this was the magenta line. Then you could have something along the lines of, say, like 4, 7, 5, and 6. And this would be valid as a red band line because there are no repeats here. And they form a set of consecutive digits, 4, 5, 6, and 7. So that's an example of how Renban lines work. Wow, there's a lot of rules here, and all of it is in the fog. Well, not all of it, because this is obviously not in the fog, but anyways. For digits along a yellow Nabner line, digits along a yellow Nabner line cannot repeat, and none may be consecutive. So say we had a Nabner line like this. Then you could have something valid like 2, 5. Actually, I don't think that works. No, it does work. 9, 7. And this would work because there are no repeats on this Nabner line, and there are no consecutive digits along this Nabner line, right? 2 is not consecutive with 5, 7, or 9. Neither is 5 with 2, 7, or 9. And 7 is not consecutive with 2, 5, or 9, as is 9 is not consecutive with 2, 5, or 7. So that's how Nabner lines work. We also have digits along a red 10 line contain contiguous groups of cells that sum to 10. These group of cells cannot overlap, and digits may repeat freely on the line, even within sums. Oh, that's interesting. So normally that's not allowed. Normally, well, for the most part, they're not allowed. But in this case, you can have repeats in the sums. You can have repeats along the line, period, but you can also have repeats along the sum. So what that means is, say we had a line like this, right? Then you could have something like, say, 1, 1, 8, 3, 7, 2, 4, 6, and 2, 8 here. And this would be valid because you can break each segment of the line. You can break the line into segments which sum to 10, or groups which sum to 10. So this would be 1, 1, 8 sums to 10, 3 and 7 sum to 10, 4, 6 sums to 10, 2 and 8 sum to 10. What you cannot, though, have is, say, something like, I don't know. You cannot have something like, say, 1, 2, 4, 3, because even though this segment adds up to 10, the problem is this would not, right? So you can't have cells that are part of multiple segments along this 10 line, right? So if this were 1, 2, 3, 4, 1, 2, 4, 3 adding up to 10, the 7 and 4 don't add up to 10 here. So that's not valid. Or if you tried going this way, 2, 8, 4, 6, and 3, 7 add up to 10, but 4, 2, and 1 does not. And you cannot include the 3 because it's part of this segment here, 3 and 7 adding up to 10. So that's how 10 lines work. We have digits along a thermometer must increase starting from the bulb end. So say this was a thermometer here, and we tried to have something like, I don't want that. Say we had something like that. This could be something like, say, 3, 4, 7, 9. And this would work as a thermometer because from the bulb end, you're continuously increasing. What you could not have is something like, say, 3379, because it's not increasing from this cell to this cell along the thermometer. And that's an example of how thermometers work. We have digits along each arrow must sum to the digit in the circled cell. So imagine this was essentially an arrow. So if that means if, for example, you had, say, 3 and 4 here, this would have to be 7 because the digits along an arrow must sum to the digit that's in the circle that the arrow comes from. And that's an example of how arrows work. And finally, cells with a filled circle must be odd, and cells with a filled square must be even. And those are all the rules, and there are quite a few of them. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we have this to work with. These three must be the same low or high polarity. And on top of that, they cannot be, because, okay, on a German whisper line, or a whisper 5 line, as I like to call them, you'll always alternate between low digits and high digits, the low digits being 1 through 4, the high digits being 6 through 9. And the reason why is what digits can be next to a low digit, which is 1 through 4. Well, 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to only 9. So next to a 1 through 4, you're guaranteed a digit from 6 through 9. Next to a digit from 6 through 9, what digits can be next to it? 9 can be next to 1 through 4, 8 can be next to 1 through 3, 7 can be next to 1 or 2, and 6 can only be next to 1. So next to a high digit, which is 6 through 9, you're guaranteed a digit from 1 through 4. So this will always alternate between low and high. So whatever set is here must be different than, let's make this pink actually, must be different from the sets that are here. That means, and this must add up to 10 with this digit. So this is the one set. This must be the other set. We have all the pink sets now. And these are all in between this set and this cell. So, say these were all low. Well, this would then have to be 2, 3, and 4 here, and this would have to be a 1. Because for them to be in between the digits in the circles, this has to be, if we tried any other combination, it just wouldn't work, right? Say we had 2 here. That would mean 1, 3, and 4 are here, but then there's no way to have all 1, 3, and 4 between 2 and another positive digit. So this has to be 1 or 9, which means this is 1 or 9 here. This has to be 2, 3, 4, or 6, 7, 8. We're not sure which. 4 and 6 can only be next to 1 and 9 respectively. So this must be 4 or 6 here. This is, which is next to the other 1 or 9 here. These must be 2, 3, 7, or 8. Which means what digits that are high can be next to these two, right? If it's either next to 2 and 3, or if it's next to 7 or 8, you have to have the other 2 or 8 here, right? Because you cannot have the 1 or 9 here because they're both taken in these cells. 4 can be next to 2 or 8. 6 can be next to 3 here. So this is guaranteed to be 2 or 8 here. These digits are in between this cell and this cell. Well, if it's 5 here, the problem is these would both be of the opposite set of the pink ones. These would be part of the orange set. And 5 and 1, or 5 and 9, can only have 3 unique digits between them. So therefore, this is not possible to have 5 unique digits in between them. So this must be orange, which means 5 has to be one of these two digits here. This is orange. It cannot be 1, 9, 2, or 8. So it's 3, 7, or 4, 6 here. But say it's 4, 6. That would have, so you have 1 to 6. That you cannot have 5 unique digits in between that. If you have 9 and 4, you cannot have 5 digits in between that. So this cannot be 4 or 6. It's 3 or 7. This is the orange 3 or 7. We have a guaranteed 2, 3, 7, 8. So these digits must be 5 and 4 or 6. We're not sure which. Okay. If this were 3, this would be guaranteed to be 6, 7, 8 as a pair, and 9. But then that would be 7 and 9 here, which is not allowed. So this cannot be 3 and 6, which means this has to be 2, 8, and 4. So the pinks are all lows. So these are all lows, which means the oranges are all highs. So this is guaranteed to be 4. This is guaranteed to be 9, 1. This is 7 then. This must be 8. And this must be a 2, 3 pair. This can't be 4 anymore because of the 4 in the box. Okay, these digits add up to 5. So this is 1 through 4, but this is 2, 3, and 4 only. This is 1, 2, or 3. If we had... These digits are consecutive, so this must add up to an odd sum. This is odd, so these must add up to an even sum. Okay, so we don't need the coloring anymore here, so we can just delete that. If we had 8 here, this is odd, because cells with a filled circle must be odd, so this is 3, 5, or 7. These are consecutive. It cannot be 1 and 2 here. These 3 unique digits always add up to at minimum 6. And it has to be at least 7 then. So this is at least 3 and 4, but this can't be 4. 3, 4, 4, 5 potentially. 5, 6, 5, 6, 6, 7, 6, 7. This is only 12 at most, because that's 3 and 9 at most, and it has to be an odd sum. So this cannot be 6 and 7 then. This is either 3, 4, 4, 5, or 5, 6, adding up to 11. So it adds up to 7. It could add up to 11. So it's 7, 9, or 11 here. So it could be adding up to 7. 1, 6, 2, 5. Cannot be 3, 4. Could add up to 9. 1, 8. 2, 7 doesn't work. And 3, 6 does work. Or if it's 11, this is 2, 9, and 3, 8. That's possibilities. Okay, this cannot be 5 or 6 because of the 5, 6 pair in the column. So this can't be 5 or 6. This is guaranteed to be a 4, which is consecutive with 3 or 5. So this adds up to 7, or it adds up to 9. So this cannot be 9 here. That works that way. So if it's this can never be 8. If this were 8, that would not 8, 1, and 2 at minimum adds up to 11, and this only adds up to 9 at most. So this has to be 2, which means this adds up to 9. So again, this can't be 7 because of 7, 1, and 2 adds up to 10 at minimum. So this is 3 or 5. 2 can be with 1 or 4, so that would be 1 or 4. 1 or 6 to add up to 9. Or, so say this was 4 and 3. That would guarantee this is 5, but then that would add up to a minimum of 5, 1, and 2. So this cannot be 4 and 3 adding up to 7. It must be 4 and 5 adding up to 9. That makes this 3. The 2 must be with 1 and 6, or 3 and 4 to add up to 9. The 3 must be with 1 and 5, or 2 and 4 to add up to 9. We have 1, 8 here. Cannot be 2, 7, or it's 3, 6. So this is 1, 3, which makes this 2 or 4 here. Okay, this digit is the same digit. This 5, 6 pair eliminates 5 and 6 in the rest of the column, so this can't be 5, therefore this can't be 1. Remaining digits in column 4. We have 2, 6, 7, 8. Okay. What does that tell us? Not too much. So this digit must be this exact same as this digit because it's a palindrome line. And it cannot be 2 here, it cannot be 7. So this is 2, 6, or 8 here, which forces this to be 6 or 8. We have a 6, 8, 6, 8 pair in row 4, which eliminates 6 and 8 in the rest of the row. This can't be 6, so it's 5, which makes that 6. So this can't be 6 here. Therefore, this can't be 1. This becomes a 3, 4 pair, adding up with 2 to add up to 9. This digit then cannot be 2, 3, 4, 8, or 9. It could be 1, 5, 6, or 7. But because of the 5, 6 pair in the column 5, this can't be 5 or 6, so this can't be 5 or 6 here. It's 1 or 7. Okay, because this is a palindrome line. Okay. What digits can be here? Say this was a 7. Okay, so can 2 ever be here is more the question. If we have 2 here, we're guaranteed a 7 here, and then 1 out of 6 or 8, which is consecutive with 7, so that's not allowed. So 2 cannot be here. Therefore, we know 2 has to be one of these 2 digits here. And this is 6, 7, or 8. This is a sum of 3 digits, but 2 of them can be here. 2 cannot be here. This is at minimum 1 and 3. You could have 1, 3, and 1 here, which would add up to 5, but we can't have 5 here because of the 5 in the box. So this is 6, 7, 8, 9, cannot be 6, so this is 7, 8, or 9. Okay. This, if we try to have non-ones here, this is at minimum 3 and 6, because 2 has to be here, 4 and 5 has to be here, and 3 and 6 already add up to 9, which is not allowed. So we're guaranteed a 1 has to be one of these digits. It could be 1, 3, 1, 3, so then this would add up to, at most, 5. But it cannot be 4, 5 because of the 4, 5 in the row. So it could be 1, 3, 3, I guess. 1, 6, 6, 1, 1, 6, 2. Cannot be 7 or 8 here. So this is guaranteed 1, and we have either 3 here or 6 here. Interesting. Hmm. We don't know if this Nabner line is the same Nabner line here. It could be different ones. The rest of column 3 is 1, 5, 6, 7, 8, 9. This can't be 5, though, because of the 5 in the row. Hmm. Huh. We don't know this is the same. This doesn't have any restrictions on it. This doesn't really have restrictions on it because red could be here. So that's not helpful. We know if this is 2, 3, this is guaranteed to be 1 here. So this can never be 1. Obviously, if it's 1, 4 there, that obviously can't be 1. So this could be 2, 4, potentially. 2, we have 4 through 9 here. This is 2 through 8 without the 3. So that's not helpful. We have a 6, 8, 6, 8 pair in row 4, which means the remaining digits in row 4 have to be 1, 3, and 9. But say we had a 9 here. Well, actually, we have a 1, 3, 9 triplet in box 6, which eliminates 1, 3, 9 in the rest of the box. So this cannot be 1, 3, 9, whereas the 9 in box 6, it must be one of these two digits. This then cannot be 9. It cannot be 3 because of the 3, 4 pair in the box, so this must be 1. So this is 1, which means this can't be 1. That's a 3, 9 pair. That eliminates 3 and 9 in the rest of the box, so this can't be 3. This is 1. That's 4 adding up to 5. So this cannot be 1 here. This is 2 or 3. Interesting. This can't be 4. So this is 1 and 8 adding up to 9. So this must be, so this is 8, which makes this 6, which makes that 6. So this cannot be 6 here. This can't be 6. This is one of 7 or 8. Can we have 1, 6 here? No, because if this is 1, 6, the problem is this is guaranteed to be 1, 6, 2, and 1, which adds up to 10, which is not a single digit. So this is 1, 3 as a pair, which eliminates a 1 and 3 in the rest of the column. This can't be 3, that's 2, which makes this 3, which means this can't be 3, that's 4 and 3 there. This 1 eliminates 1 here, so this is 7, which makes that 7. This can't be 7 anymore, so it's 8. Therefore, this cannot be 2 and 8. It's 2, 7 as a pair. 7 cannot be here. These 3 digits must add up to, at minimum, 1, 2, and 3. And you cannot have a 6 here because that adds up to 1, 2, and 6 at minimum, which is 9 plus 1, which is 10. So this is guaranteed to be 1, 2, 3 here. This must add up to 6, and you can't add up to 7, so this can't be 1. So this is 3, this is 1. That means this can't be 1. This is a 2, 3 pair. This 1 eliminates 1 here. Remaining digits in box 8 are what? 6, 8, and 9. And this can't be 6 because of the 6 in the column, so we have an 8, 9 pair in box 8. So therefore, this cannot be 8 or 9. It's 6. That leaves us as 1 or 2. That could work. Either of those works. Remaining digits in column 6 are 4, 5, and 9. This digit is greater than both of these two digits, and this is at minimum 4, so this can't be 3. This is 9, which makes that 3. So this cannot be 9, this cannot be 8, because these two digits are smaller than this. Remaining digits in row 5. We have what? 2, 5, 6 remaining. This can't be 2 because of the 2 in the box. This can't be 6, so this is 5, which means this can't be 5. This is 2 6s a pair. That leaves in the rest of box 4 an 8 9 pair, and the rest of box 6 a 5 7 pair. Okay. This is 5 and 1, which add up to 6. So this has to be less than, it has to be 4 or less. So this could be 1, 2, or 4. Cannot be 3 because of the 3 there. This is 1, 2, and 3, and plus 3, which adds up to 9. So this is 9, that's 8. This is one Nabner line. So 7, 6, and 8 cannot be here. And this can't be 9. This cannot be 1 anymore because it's next to the 2. It's consecutive with a 2, so this must be 5. This can't be 1 or 5. It's 9, which eliminates 9 in the rest of the column. This can't be 8 because of 8 in the row. This can't be 6 or 7 because 6 or 7 in the rest of the row. This can't be 5 because of the 5 in the column. Okay. Remaining digits in row 7 are 6 through 9. But this cannot be 9 because of the 9 in the box. So this is 6, 7. This 6, 7 pair eliminates 6, 7 here. So this is 8, which means this can't be 8. This can't be 8. This 8 eliminates 8 here, so this is 9, which makes this 8. This 6, 7, 8 triplet eliminates 6, 7, 8 here, so it's 9 here. Five, 1. What are the digits here? It must be 1 through 5. We know... Oof. Can this ever be 5? I think the answer to that is no. Because we know this is a set at least. So either this is 4, or this is a set. Heck, we could have 5 digits. No, we can't. Because this is that minimum 1, 2, 3, which adds up to 6. So either this is a set with this, which makes that 4, or this is a set with this, which means this adds up to 4, so it would have to be 1 and 3. So can this ever be 2? I think the answer to that is no. Right? 5, 1, 2 would require 2 here, or 1, 1 here, which is a duplicate in that box. So this cannot be 2. This is 1 or 4. This must be 1 or 4. We also know in column 3, where's the 1? Cannot be here, cannot be any of these cells, so it has to be one of these 3, which means this can't be 1. This is 4. This can't be 1 or 4. This 4 eliminates 4 here, so this is 5, which makes this 1 and 5 adding up to 9. So this is 1, that's 2. 2 and 8 add up to 10. These two digits must add up to 10, and you can only have 2 and 8 here. So this is 2, that's 8, which eliminates 8 here. This can't be 1 because of the 1 in the row. Where's the 1 in column 3? It has to be here. So this is 1. We can't have 5 here because of the 5 in the box. This can't be 5, and this can't be 4 or 5 here because of the 4 or 5 in the row. Okay. Remaining digits in column 2. We have 1, 3, and 5. 5 cannot be here, so this must be 5 here. This can't be 3 because of the 3 in the row, so this is 1, that's 3. The remaining digits in box 7 then are 2 and 4. So this is a 2, 4 pair. remaining digits in... Let's see. Where to go next? We do not have a 9 here. Okay, remaining digits in row 8. There's no 2, no 1, 2, no 3, no 5, or 9. So it could be 4, 7, 6, and 8. This can't be 8 because of 8 in the column. Rest of row 9 is 1, no 2, 3. Could be 4, 7, or 5. This can't be 1 or 4. This can't be 4 because of the 1, 4 pair in the column. We have a 5, 7, 5, 7 pair on this red band line. And again, we can't have duplicates. We can't have repeats on a Renban line. So that eliminates 5 and 7 in the rest of the Renban line. So this can't be 7. This is 6. This can't be 6 or 7. This 6 eliminates 6 here. So this is 2. That's 6. This must then, the 2 eliminates 2 here. So it's 3 and 2. This has to have 2, 3, 4, 5, 6, 7 here on this Renban. So this is 4, which eliminates 4 here. So that's 2 and 4. 2 eliminates 2 here. So it's 7 and 2. This can't be 4, 6, or 7. That makes that 8. This 5, 7 pair have to be different ones. This 2, 6 eliminates 2 and 6 here, so it's 7, which means this is 8 to be between the 7 and 9. The 7 eliminates 7 here, so it's 6. The 7 eliminates 7 here, so it's 5, which eliminates 5 here, so it's 7, which makes that 5. This cannot be 4 or 5 anymore. The 7 eliminates 7 here, so it's 1 and 7. The 6 eliminates 6 here, so it's 7 and 6. We have 8 ones, which means we know where the last one has to be. It has to be here. So that's 1. We should have 8 twos, which we do. We know where the last 2 has to be. It has to be there. We have 7 threes, so that's not that helpful. We have 7 fours, not helpful. We have 8 fives, so we know where the last 5 has to be. It has to be here. We should have 8 sixes. We do. We know where the last 6 has to be. It has to be there. We have 8 sevens. We know where the last 7 has to be. It has to be there. We have all 9 eights, so we don't have to worry about that. We know where the 9 is in row 3. It has to be here, but we don't have a restriction on in rows 1 and 2. That leaves this digit as a 3. So now we have all the 1s, all the 2s. We have 8 3s now. So we know where the last 3 has to be. It has to be there. We know now in column 9, the 4 has to be here. So this is 4, which makes this 9, which makes that 4, which makes this a 9. And that's the solution. Yeah, I mean, seems pretty easy. Just normal logic that you have to go through, and you just have to figure that out here. And everything else sort of flows just sort of naturally once you get more information. As always, Megan33 does a really good job with his Fog of War puzzles, so it's very, very nice job. And I'll see you. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.